All right, so we've already talked about how to graph an inequality, a linear inequality, and now we're going to talk about how to solve systems of inequalities. So two or more inequalities that are graphed on the same coordinate plane. This is very similar to how solving systems of equations by graphing, so I'm just going to kind of review those steps as we go through these problems. First of all, we need to graph these two inequalities. We're going to graph them on this coordinate plane together. In order to graph a linear inequality, we would like to have it solved for y, put it into slope-intercept form. Remember, that's y equals mx plus b. Of course, for these problems, this will be less than, greater than, less than or equal to, greater than or equal to, instead of equals. All right, so here we have our two equations, or inequalities. I'm going to highlight them different colors from each other. That way we can keep track of which is which over here as well. What we need to do first is solve them for y. So I like to write them side by side. It's just my style. That way I can keep track of them. And again, I will color code them to match. Okay. Now let's begin solving. So we like to draw the line down, and remember we want to get the y alone. We want to isolate the y, and so we need to move everything away from it. I'm going to subtract 3x from both sides to get that away. So we have 4y is less than, and we cannot, sorry, you can't see, we cannot combine these because they are not like terms. So we write negative 3x plus 28. And then we have 4 times y. We need to do the opposite. So we're going to divide every term by 4. So now we have y is less than negative 3 over 4x plus 7. All right, now let's look at the other one. Let me switch colors so we don't get the stuff lost. Okay, draw a line down. We want the y alone, so we're going to move the term with x. So now we have negative 2y is less than or equal to negative x plus 0, but we don't need to write plus 0, so I'm just going to put negative x. And we have negative 2 times y, so we're going to divide both sides by negative 2. Something interesting happens that you may or may not remember, but hopefully you do. When you multiply or divide by a negative number, this sign, the inequality sign, turns around. So now instead of being less than or equal to, it's greater than or equal to. That's a super important part. Also, just want to point out we had negative x over negative 2. Remember that there's always a 1 that's implied there. And so negative and negative makes positive, 1 over 2x. And now we need to graph these. Just for remembering, the slope and the y-intercept are what we're going to use to graph. The slope is the coefficient of the x, so negative 3 over 4 will be the slope. The y-intercept is 7. For this one, the slope is 1 over 2, the coefficient of the x, and we don't have any number out here for the y-intercept, so that will be 0. All right, and again, another reminder, because these videos are for review, remember that negative 3 over 4 means down 3 to the right 4, or you could also go up 3 or backwards 4, depending on what you have room for. All right, so let's graph. We'll go with the yellow equation first, which is this one. So 7 is the y-intercept. 1, 2, 3, 4, 5, 6, 7. We're going to put a point there. We need to go down 3 and to the right 4 for our slope. 1, 2, 3, 1, 2, 3, 4. All right, we could do that again if we wanted. Down 1, 2, 3 over 1, 2, 3, 4. All right, you only need 2 points to make a line, but hey. All right, and then we need to connect those. Now remember, we need to look at this inequality sign to decide if it will be a dotted line or a solid line. Because this is simply less than, it's going to be a dotted line. And the other important thing is to know where we're going to shade. Are we going to shade above or below this line? Well, it says less than, so less than means below. Below would be this part over here underneath the line. All right, so if this was all, this is the inequality. These are all the solutions to this inequality. Okay, let me highlight that actually. Okay, now let's look at the other one. For the other one, the y-intercept is 0, so we're going to put a point at 0, and our slope is 1 over 2, which means up 1 over 2. And again, we can do that again, up 1 over 2, however many times you want. Now, deciding if this is a dotted line or a dashed line, we need to look at our inequality symbol. It is greater than or equal to. The or equal to means that this is going to be a solid line. And the greater than means that we're going to shade above this line. All right, so tell me what you notice. Hopefully you notice that there's a part that is shaded both colors, this area right here. So if I can find my pencil, I'm just going to shade that. Nope, my pencil broke. I kind of want to shade it a little darker so you can focus on it. Maybe. This area here is the solution set. Everything in this area works for both inequalities. So while yes, this pink part, these are solutions just to this inequality, and these yellow are solutions just to this inequality, but these points, these are a solution to both. All right, now let's look at these. Is it a solution? So we're going to try to decide which ones are a solution to that inequality or system of inequalities. So the coordinate 1, 3. 1, 1, 2, 3. Is that a solution? Yes, because that's in the double shaded area. 3, negative 5. 1, 2, 3. 1, 2, 3, 4, 5. That's a solution for our yellow equation inequality, but it is not a solution for the pink one. So this is not a solution to the system of equations. 0, negative 5. 0, 1, 2, 3, 4, 5. Again, that's not a solution to both, so it's not a solution to the system. Negative 2, 0. Negative 2, 0. That is a solution to both. That's a solution to the system. Now, you do need to be a little bit careful, because if I ask, for example, about the point 1, 2, 3, 4, 1, 2, 4, 4. If I asked about this point, it's right here. But the answer for that is actually no, because the line is dotted, so it's kind of like a cliff. If you get on that, you like fall into the Grand Canyon. All right, so that's not a solution. However, this point here, right there, that's 2, 1, the coordinate 2, 1, that is a solution because this is a solid line, so that they're still standing on the cliff. All right, hopefully that was a good overview. We're going to go a little quicker through these two problems. All right, first we need to, I'm just going to highlight these so they're ready. First, we need to graph them. In order to graph them, we need to solve them each for y. So we have y is less than or equal to 3x plus 1. We also have x minus y is greater than 1. Okay. This one, it's already solved for y. That's awesome. We don't have to do that work now. So we can just pick out the slope and the y-intercept and graph it. The slope is 3, which we like to write as like 3 over 1, just to keep it consistent. Up 3 over 1. And the y-intercept is 1. So I'm going to actually go ahead and graph that one right now. Y-intercept is 1. The slope is 3 over 1. 1, 2, 3, 1. I'm going to check back and look at my inequality symbol. This says less than or equal to. The or equal to means that we will have a solid line, and the less than means we are going to shade below the line. All right, let's look at the yellow equation. This one is not solved for y yet, so we need to solve it for y. So draw a line, subtract x from that side and the other side. We have negative y is greater than negative x plus 1 because these are not like terms. And now we have negative y. That's the same as negative 1 times y. So we need to divide by negative 1. When you multiply or divide by a negative number, the inequality symbol turns around. All right? So y equals x minus 1. All right. The slope is 1, or 1 over 1, because that's the coefficient of the x. The y-intercept is negative 1. So let's go ahead and graph it. Negative 1, we put a point. The slope, 1 over 1, up 1, over 1. Okay? Referencing this again, this is less than, so it's going to be a dotted line because it doesn't have or equal to. And it is less than, so we shade below. Okay, so again, I'll kind of go over this. You can see that this area in here, this whole spot, where they're both shaded, these are the solutions. All right, one more. All right, so first things first, we need to solve each equation for y. Now, I look at these equations and I feel like something very specific is going to happen. You may be like, oh, something special about these, or maybe not. That's okay, either way. All right, so for our top equation, we need to subtract 2x from both sides because we're trying to isolate the y. And we need to divide both sides by 5 to get the y alone. Y is greater than negative 2/5 x plus 4. All right. We know the y-intercept is 4. So 1, 2, 3, 4. The slope is negative 2 over 5, down 2 over 1, 2, 3, 4, 5. It will be a dotted line because this is less or greater than, not greater than or equal to. So we'll have a dotted line. And it says greater than, so we will shade above. All right, next, we're going to subtract 2x to try to isolate our y, get the y alone. We're going to divide by 5. Y is less than negative 2 over 5x minus 1. All right. Hey, you might notice these have the same slope, and you might recall from before that the same slope means they will be parallel. So it's going to be very interesting to see how this looks on our graph. All right. So we're going to graph. Y-intercept is negative 1. Slope, negative 2 over 5, down 2 over 5. It says less than, not less than or equal to, and so these are going to be dotted lines. And it says less than, so we need to shade below. What do you notice? On this one, the answers are where they were shaded both colors. On the one up here, the answer is where they were shaded both colors. But on this one, there's nowhere that it's shaded both colors, which means there is no solution to this system of inequalities. All right, I hope that helps. See you later.